Okay, up until now we've been dealing with movement on perfectly smooth surfaces, okay, but that's not realistic. Usually contact between object and surface, there's a degree of roughness there, okay, and when an object moves there's friction, okay, resisting that movement, okay, and friction always opposes the motion, yeah, it's trying to, that roughness in that contact between the object and the surface, that roughness is trying to stop the object from moving. So it always opposes the direction of motion. So in this case, if we've got a tension, a string or something pulling the object in that direction, okay, to the right there, okay, it would be wanting to accelerate to the right, the friction would force would oppose it, and it's a resistance ultimately, okay. Now it can stop an object from moving, of course, okay, because if that tension is not, in that string is not strong enough, okay, to overcome the friction, then the object won't move, okay. But there will come a point when if you pull hard enough, okay, that friction won't be able to hold out anymore, okay. So we need to be able to give a value to friction, okay, and what we're often interested in is what's the maximum it can be, that value of friction, what's the most it can do, okay. And then, of course, then if we want to be able to get this object to move, that tension then needs to be able to match it and become more than it to make it move. Okay, so how do we calculate the value of friction? Well, first of all, we need to know something about the coefficient of friction. Okay, so this term here, literally, coefficient of friction, literally measures the roughness of the contact between the object and the surface, okay. It's given a special letter, so a Greek letter called mu, okay. So you just sort of write it like that, okay. So it always has that Greek letter mu, okay. Now the value of mu is usually between 0 and 1, okay. So you'll see that in exam questions, it'll be between 0 and 1. Now if it was 0, okay, 0 would mean that it's a perfectly smooth surface, okay. So there's no friction. Okay, so 0 means perfectly smooth, no friction. So, in questions with friction, you're not going to get that, are you? You're going to get a value which is higher. Okay, and of course, the higher the value, the more roughness there is there. Okay, and as I said, the values you get in exam questions are between 0 and 1. Okay, now to calculate friction, okay, or to work out the maximum possible value of friction, well, it's quite a simple formula. The maximum value of friction is given by mu, that value of coefficient of friction, at times the normal reaction, okay, the perpendicular reaction. So that's all it is. Okay, that'll give you the maximum friction value. And of course, for this object to move, okay, T has to match this and overcome this. Okay, if T doesn't, then it won't move. Okay, and what's important to remember as well is that the friction will just match that, it'll sort of react to the opposing force. Okay, so it will only actually be equal to mu r, okay, when T is able to match it, okay, and become greater than it. All right, but if the pulling force here is less than this, then of course the friction value will only match the tension value. It's not going to be greater than it, because the friction will only react to that tension, okay. But in the questions that we're going to be dealing with today, this is the formula we're going to use here to calculate friction, okay.